Corsair, Apple Floppy Days, Commodore, Tandy Floppy Days, Atari, TI Floppy Days. The weekend comes, the disk drive hums, ready to code for you. These days we're all happy and free. Those floppy days, the games we play, you shared with me. Those days, Motorola, Intel 6502, graphics and text are there to view. Composite, color, or RGB, program fun for you and me.
Floppy Days is recorded in a live studio.
Inside PC Floppy Days, ST Amiga Floppy Days, Junior Sinclair Floppy Days, Classic Days, Microwaves, geeking all week with you. These days we're all happy and free. Those floppy days, the games we play, you shared with me. Those days, these floppy days are yours and mine. These floppy days are yours and mine. Floppy days.
The TRS-80 Model 3.
Introducing the Apple IIc.
Atari 1040 ST.
Commodore 64.
PC Junior, new from IBM.
Discover Atari.
At his Radio Shack Color Computer 3.
Introducing the Timex Sinclair 1000.
For computer, this is the one. Texas Instruments home computer.
A wonder computer of the 1980s. The Commodore VIC-20.
Hi everyone, and welcome to episode 99 for May 2020 of the Floppy Days Podcast, where we look at home computers of the 70s and 80s across the globe, not just the US. My name is Randy Kindig, the host of this podcast. This episode is one in a series of episodes on one of the iconic British machines that was so important to the home computer revolution, the BBC Micro. In episode 97, I had an interview with one of the key members of the BBC Micro team, Mr. Steve Furber. In this episode, with Steve's help, I was able to get an interview with another key member of that team, Mr. Hermann Hauser. Last episode, number 98, I summarized the history of the BBC Micro, and I don't want to repeat that here, but I want to give you just a bit of information about Hermann to help set the stage for the interview to follow. Chris Curry and Mr. Hauser set up a company called Acorn Computer Limited, and in January 1979, they launched their first product, a microcomputer kit named the Acorn System 75. The name Acorn was chosen because the microcomputer system was to be expandable and growth-oriented and appeared before Apple Computer in a telephone directory. Their follow-up product was a microcomputer called the Atom. After it had been released into the market, Acorn, due to an idea proposed by Hermann, decided to build an improved 6502-based machine with far greater expansion capabilities, the Proton. Hauser quickly pulled in Steve Furber, who had been working for Acorn on a voluntary basis, and Sophie Wilson to help complete a revised version of the Proton, which met the specifications that the British Broadcasting Corporation was shopping around to find a partner for their planned literacy program. BBC visited Acorn and were given a demonstration of the Proton. Shortly afterwards, the literacy program computer contract was awarded to Acorn, and the Proton was launched in December 1981 as the BBC Micro. Hermann Hauser believes that if he had had just a little more foresight all those years ago, the world would now talk about Acorn-compatible rather than IBM-compatible computers. Wouldn't that be interesting? Anyway, I'm very excited and proud to have gotten an interview with Hermann, and I enjoyed talking with him very much. I hope you enjoy it as well. I'm still planning in upcoming episodes to cover all of the usual topics on the Beeb, such as its tech specs, modern upgrades, websites, and a ton of other information about the machine. Before we jump into the interview, I'll spend just a moment to let you know about any new acquisitions I've managed to get for my hobby and any hobby-related things I've been working on. Please enjoy.
Hello, I'm Steve Furber. I'm a professor of computer engineering at the University of Manchester in the UK, and I'm talking about the time I spent in the 1980s at Acorn Computers in Cambridge, developing the BBC Micro and the early versions of the ARM microprocessor. And you're listening to Floppy Days.
Okay, now I'm going to talk about new acquisitions. I'm going to keep this lean. I really wanted to focus on the interview for this particular episode. I have a lot of things in flight, a lot of things that I'm in the process of acquiring that I'll talk about the next time. But there are a couple things I want to talk about today. First of all, I have acquired a Heathkit ET3400 microprocessor trainer. This is something I've actually had on my list to get for quite some time, several years in fact, and I've never found one that came up for the right price. But I finally found one on eBay, got it for a reasonable price. I'm not sure why it was less than normal. It did show that it showed the message CPU up, which basically tells you that the machine is good, and it had not been fully tested, and maybe that's why the price was less. But anyway, what this is, it's a low cost, or at the time at least was a low cost microprocessor trainer. It was designed as a learning tool to teach people microprocessor operation, programming, and applications. It was a very popular item to teach principles of computers and programming at universities in the 70s, and to educate the students about internal computer hardware and software components by self-assembly and programming the machine in pure hexadecimal language. It was delivered either in assembled or kit form. It also featured a prototype or breadboard area and allowed the students to configure the machine for a variety of different experiments and tasks. There also was an expansion chassis that allowed you to significantly extend the memory, and the input-output capabilities also were expanded so that you could use a terminal or a cassette tape drive. There also was some software available in ROM, among them an assembler and a tiny BASIC. So these came out in 1976. There were tens of thousands of them developed, so it's not actually hard to find these. They were developed in the U.S., and they were approximately $200 at the time. The processor on this particular model, the ET3400, and I say that because there were other models, such as the ET3100, but the 3400 had a Motorola 6800 processor running at 1 megahertz. The RAM was 256 bytes. As I mentioned earlier, you could expand it to several K using an add-on. And then I also mentioned the ROMs and the optional cassette expansion capability. So with the memory I/O accessory, the trainer actually could be used as a full computer, programmable in BASIC or assembly, with the ability to hook up a terminal and a tape recorder. Along with that, then I've been looking for the materials that go with it, because it didn't come with any materials, but there are several books that are available that trained you on how to use these at the time. I did find the ET3400 manual called the Microprocessors, Book 1. It covers microcomputer basics. It covers binary, octal, and hexadecimal. And it covers the 6800 and 6808 instruction set and also has a card inside the book. And it also covers programming experiments. So it's a really neat little microprocessor trainer. It's fun to play with. Once I got it, I ran through the test program and discovered that everything works perfectly well. It's got several LEDs on it, and everything works great. So I was really pleased about that, and I'm finally able to mark that off of my wish list. And then beyond that, I got some Pascal books. Pascal, I probably mentioned that in the past, is one of my favorite vintage computer languages. And I've been wanting to get the Personal Pascal book, a Personal Pascal that was developed for the Atari ST. I've been trying to find the book for that. And there was a package of books, actually included 3 different Pascal books that had the Personal Pascal for the Atari ST in it. And I made an offer that I thought was very reasonable and got it. So one of the books is called O Pascal by Michael Clancy. Another one is Software Tools in Pascal. And the reason I thought this was interesting is that one of the authors is Brian Kernighan, whose name you might know. He worked at Bell Labs and contributed to the development of Unix alongside Unix creators Ken Thompson and Dennis Ritchie. And Kernighan's name really became widely known through co-authorship of the first book on C programming with Dennis Ritchie. And then the Personal Pascal book that I mentioned, this was put out by Optimized System Software, the people who wrote DOS, BASIC, Mac 65, Action, and other things for the Atari 8-bit computers. And they dipped their toes in the ST market with Personal Pascal. And it's a very well done package. And it's really a complete language system for the ST, which consists of an editor, compiler, linker, libraries, and demonstration program. And it also has a desktop-style manager program that gives you an IDE and is really a nice package. So I'm very happy that I was finally able to get the book for Personal Pascal. And that's it for new acquisitions this month.
Hi, it's Earl Evans, retro computing podcaster and enthusiast, and you're listening to Randy Kindig on the Floppy Days Podcast.
Okay, let's talk about upcoming shows. The show schedule is kind of a mess, as everyone is aware, with the COVID-19 pandemic. A lot of shows are going virtual, at least the ones that are most imminent are. The ones later in the year haven't made that call yet. They could end up going virtual. They could end up, having the regular in-person show. I don't know. All I know is that at this point, Kansas Fest has gone virtual. It will be July 24th and 25th. It's $20 to join it as a virtual attendee. And I have signed up. This will be the first time I have been able to attend since, I think it was 2015 when I went. That should be fun. Also, VCF West has announced that they are going virtual. That is August 1st through the 2nd. Fujiyama, which is an Atari show, is August 20th through the 23rd in Langenfeld, Germany. And it looks like at this point it's still planning to be an in-person show. September 12th through the 13th, VCF Midwest in Elmhurst, Illinois. They're still watching things. It's not been announced to go virtual yet. This is one of my favorite shows, and I actually hope that I can attend this in person. October 10th through the 12th is when VCF East was rescheduled to at the InfoAge Science Center in Wall, New Jersey. October 24th will be the Chicago TI International World Fair. It's supposed to occur at the Evanston Public Library in Evanston, Illinois. Again, it's still planning to be an in-person event. Tandy Assembly, October 30th through November 1st, still planning to be an in-person event. And then, although not yet announced, the World of Commodore is typically the first weekend in December in Toronto, Ontario, Canada. And again, I don't know if that will actually be in person or a virtual event, but that's what's going on with shows at this point.
Hello, my name is Jay Balakrishnan, and I've been a pioneer in the microcomputer industry since the birth of personal computers in 1978. You are listening to the Floppy Days Podcast.
Okay, here's the interview with Hermann Hauser. Hermann Hauser is an Austrian-born entrepreneur who's primarily associated with the Cambridge technology community in England. He's truly an innovator and an entrepreneur in all senses of the word. His involvement with technology companies since the 80s is a very long list and is extremely impressive. Hauser was voted the UK's Computer Personality of the Year of 1984. In 2010, Eureka had Hauser in its 100 Most Important Scientists. He became patron of the Center for Computing History in December 2011, 30 years after the launch of the BBC Micro. Hauser's role in Acorn was portrayed by Edward Baker Dooley in the BBC drama Micromen. This interview took place on May 12th, 2020. Okay, so maybe you can start out by just talking about a little bit about where you live today and what you're currently involved in.
Today, rather than at the BBC Micro Days.
Yeah, just real quick, what you're doing today.
Yeah, well, I'm now a venture capitalist with Amadeus Capital Partners, and I spent some time here in New Zealand during the northern winter to hibernate down here because my wife is a Kiwi and we have a sort of extended family here on the farm. And my main interest at the moment is there are really four areas. I'm a deep technology investor, so my interests at present are AI and machine learning, of course, blockchain and smart contracts, synthetic biology, and quantum computing. These are four sectors that I believe are going to change our lives within the next 5 to 10 years, not 10 to 30 years.
That sounds like that keeps you busy. That sounds pretty interesting.
It keeps me extremely busy, and I have a great time at the moment because deep technology finally is in. You know, people believe that deep technology can make changes.
Can you in a short paragraph summarize your history with computing?
Yes, it all started with my brother and I building a shoebox computer, which was I think an 8-bit adder with marbles rolling down the side of the shoebox, you know, and a flip-flop adds 8 bits with these mechanical flip-flops, which we very much enjoyed as sort of teenagers. And then I used the Cambridge computer, first the Titan, which was still a locally a local computer, because Cambridge with the ETSAC produced the first usable computer in the world. And then the IBM 370. So that was because I needed it for my physics PhD at Cambridge. And just after I finished my PhD, we then started Acorn Computers to first produce home computers, then the BBC Micro. And then throughout my history as first an entrepreneur and then a venture capitalist, I've always stayed close to the computer sector from the sort of semiconductor side up with ARM and now GraphCore, which is the chip for AI.
Okay, perfect. Can you tell us how you got involved with the BBC Micro project and what led up to that?
Yes, we founded Chris Curry, my partner, and I founded a company called Acorn Computers in the UK, which produced home computer kits during that time when people were very excited about microprocessors and wanted to build their own home computer using 6502 and Z80 8-bit microprocessors. And then the BBC decided that they wanted to educate Britain in computing and decided that the only way they could do this properly is running a series of BBC programs called the BBC program, the computer program, and they needed a computer to go with it because they rightly argued that the only way people can really learn about computers is by actually using one. and they went out to 6 companies to tell them what specification they wanted for their computer. And there was a little competition between 6 British companies, and we won that competition. And we then became the supplier of the BBC Micro.
So what exactly was your role in this? What was your particular skill set or role in this?
Well, we're very lucky in Cambridge that we've got lots of high quality people to hire. And that really was my job, was to find the people like Steve Furber and Sophie Wilson, to put together and lots of others in the team to produce the hardware and the software, because Sophie actually wrote BBC Basic, which is one of the nicer basics to use, and it has, because of Sophie, it also had a wonderful facility of directly calling assembly routines from BBC Basic. So if you really wanted to speed things up and go down to the metal, you could do that. And that really probably was the single proudest thing that we've achieved at Acorn, that because the BBC Micro became the standard in British schools and BBC Basic became the standard language that all the school children learned, we then created a generation of programmers in the UK, which arguably is responsible for the games industry in the UK and the fact that the UK is such a software powerhouse.
And so what you ended up designing at the time was like way ahead of anything that had been developed to that time. Can you talk about the specs that you were given and what the challenges were in trying to meet the specifications by the BBC?
Well, BBC, typically BBC with a guy called John Cole, who was their education advisor, basically threw everything in the kitchen sink into their specification. And we were just very lucky that Stephen had an architecture that he called the Proton. Our first product at Acorn was called the Atom. And so we stuck with elementary particles, maybe because I was a physicist. And that the Proton design, which didn't actually exist, it existed in Stephen's head, was actually quite close to that specification. So the spec was, it ran the 6502 at 2 megahertz, which was twice as fast as the Apple II. It had to have graphics capability, had to be a color, so it was color. People don't remember that the Apple II was actually monochrome. So we had a color computer. The Apple II was only text. We had text and graphics, and you could mix them. In particular, there was a specification from the BBC, which was actually very difficult to design. And that was, there had to be a video mode called the teletext mode, because the BBC broadcast a standard that was called teletext at the time on TV sets, which was a character display that all the TV sets could display. It was quite chunky, but it was quite advanced in the sense that the characters had nice rounded typeface that worked very well on an interlaced display. So it was an interlaced mode, which doesn't really mesh very well with computer design. You don't want to have a computer that produces an interlaced output. So Stephen really did the heroics to manage to fit mode 7. It was called. We had eight different modes of various resolutions, which was very important because the 6502, of course, was an 8-bit computer with a total address space that was only 64 kilobytes. And we had 32 kilobytes for the ROM, so there was only 32 kilobytes for RAM. And on the highest resolution mode, which was our high resolution graphics mode, we used 20 of the 32 kilobytes for the screen, so you only had 12 kilobytes to write your program in.
It's not much.
So it was important that there were screen modes which were much smaller, and one of the great advantages of the teletext mode, which also had chunky graphics, so you also could do a little bit of game displays. That only required 2 kilobytes, so it was a very efficient way of producing displays, and that meant you've got 30 kilobytes for your program.
So you said that Sophie Wilson built the BASIC for the machine. How did the operating system itself get developed?
Well, these were two really fantastic achievements by Sophie. First, the BBC BASIC was another case of everything in the kitchen sink. So I chaired the BASIC design committee. That was a committee that had both Acorn people, well, mainly Sophie, and the BBC in there. And the BBC wanted to have all these fancy extensions and procedures and everything. And Sophie, because she was and is probably one of the most accomplished assembly programmers, he could always think all the way down to the machine code. And therefore, he managed to implement a number of really quite advanced features, some of them deriving from BCPL. I don't know if you know BCPL is a Cambridge language that crossed the Atlantic and became C at Bell Labs. But C, the origin of C is actually in a Cambridge language designed by Martin Richards called B and then BCPL. And so it also had procedure features. It had all the one of the few regrets was that the BBC insisted on having line numbers, which the simple basics at that time had, and they wanted to stick with line numbers. And Sophie was very keen to go to labels right away, so he was far advanced. But we had to concede that one, so it had line numbers. And it was actually quite a fun thing to chair that committee defining BBC BASIC, because on one hand there was the market, which was the BBC, that had great ambitions of what they wanted, and on the other hand there was this genius of an implementer, and I had to sort of balance and arbitrate between these two. But I think the result was very satisfactory. And then you asked about the operating system. Well, the operating system, as many of the exceptional programs in the BBC BASIC, was actually written in assembler. It was not written in C or in BASIC or in any other high-level language. The whole operating system, the 32 kilobyte operating system, was all 6502 assembler. And it was all mainly written by Sophie.
Okay.
And it had some sophisticated features. When Bill Gates came to see me to sell me a MS-DOS, I said, Bill, we couldn't possibly take such a retrograde step. Look at our operating system. And by the way, when you're in BASIC, and of course Sophie was very keen to show his BASIC to Bill, because the Microsoft BASIC was the only software that Bill himself wrote at the time. Yeah. And it was a few years later, of course, our BASIC was much more powerful than Microsoft BASIC. But MS-DOS at the time was very primitive. And I could say to Bill, look, this is used very widely in British schools, and our schoolboys can write star, in BASIC, could write star, I am Johnny, and they're logged on to the local area network, and they can use the same commands to interface to the files on the file server via the network, as they can use the load and save commands to the local floppy disk. And Bill's response to that was, "What's a network?" So, we're way ahead, because every computer, we never produced a computer at Acorn that didn't have a network connection. because networking just was one of the great strengths of the computer lab in Cambridge. So Andy Hopper, who was the third director at Acorn Computers, invented the Cambridge ring, which for a while was a contender against the Ethernet as the main network that computers would adopt. It was a slot ring, and there are lots of aspects of slot rings that are, of course, much nicer than the Ethernet, but the Ethernet won out.
Tell us about how some of the unique features of this machine, which it had a huge number of ports and capabilities well beyond almost any machine of the day, or probably every machine of the day, like the tube interface and sideways RAM and ROM. How did those things come about?
Well, the tube is probably the most spectacular interface that very few people know about. I mean, the BBC Micro, as you say, had probably the richest sets of interfaces because of the BBC. That was one of the specs. It has an analog port, it had a printer port, it had an RS-232. It had the EcoNet, which was our network connection, which was also unique. Computers in those days didn't have network connection as standards. And of course, it had a floppy disk interface. But the most interesting one from a technical point of view was the tube. So the tube was a chip that interfaced, that made the BBC Micro into an I/O processor. And on the other side of the tube, so the tube interfaced to computer systems, basically, asynchronously. One was the application processor, and we had lots of them. We had an 8286, we had a 32016, which was actually by far the most exciting processor. Was a national semiconductor processor that was a very clean, had a very clean instruction set, very exciting, never really caught on. We had a 68000 coprocessor. And the tube managed two computer systems, the BBC being the I/O system and the bigger processor being the application processor, asynchronously. So we went to see Professor Wheeler, who invented the subroutine. He's the guy who somebody had to invent the subroutine, so it was Wheeler, and told him because he was the person that we always went to for advice. He also gave us a lot of advice on the ARM and the ARM instruction set, and it was him who said that we really ought to have a fast interrupt, and he taught us about the importance of I/O. But we went to see him with the tube design because it was quite an unusual design to link two systems with separate clocks asynchronously. And he said, yeah, this is an interesting design, but you do know that you can never make it work 100%. So I finally got the request to control your camera, which I've just approved. And he said, so you know that you can't make it work 100%. And that was a bit of a revelation. I said, well, why is that? Well, because if you have an asynchronous design, there are always race conditions in the instabilities in the transistors themselves. So the only thing that you can do is make sure that these errors only appear once every 10,000 years or so, and then you don't worry about it. So Steve, who designed the tube, and I went home and said, well, it's all right, we're not going to get that many errors. And as it happened, we got errors every fortnight. So it was too frequent to ignore, but too rare to really track down very easily, because you had to wait for 14 days for the next error to appear. So it was a real bugger. And this was the reason why Stephen then decided to create a design suite, which actually became a separate company for asynchronous design, to make sure that you contain the errors, that you get a very good feeling, a very good description of the errors, so you could calculate how often these errors appear, and then you can design it so that the error only appears every 10,000 years or something, so that you can forget about them. But with the tube, we had to do a lot of tweaking. But it did work in the end, and it was a success.
So something I've never come across or heard a lot about is how the machine was actually rolled out. What was that process like? Was there a big rollout, a big fanfare? What was that like?
Oh yes. I mean, one of the great attractions of having the BBC, of course, is the BBC promoted the BBC microcomputer in the computer program, and the computer program was the most extraordinary event in Britain at the time, because before the computer program, the BBC produced a program called When the Chips Are Down. And what they meant by the chips was a microprocessor. And they described how every household might eventually have a chip. And somehow it galvanized the nation. Everybody wanted to find out about these chips. And then they ran this computer program. And this is very difficult to believe nowadays, but people would go home from the pub at 6 o'clock in the evening to watch the computer program. It was a bit like, Sesame Street, or, it was a nationwide trend that people wanted to find out about this. And so we couldn't have dreamt of a better marketing campaign than the BBC promoting our computer. And they contracted with us to sell 12,000 computers in the first year. In the end, we sold 100,000. So it was just a phenomenal success.
Just in the first year, you sold 100,000? Yeah. So how did that success impact you, and what did you think about it at the time?
Well, it was just the most amazing experience. We had this little company, that was doing very well. I think we had revenues of a few million. We bootstrapped the company up. We never, we didn't have any money. We and there was no venture capital. There was no angel money. It was our £50 each. So we had put £100 into that company plus a bank loan. And within 5 years, we had revenues of 100 million. And, we went public. We had a valuation of 200 million. So it's still the only company I know where the capital gain in the company has been £1 million-fold. So every pound we put in 5 years later was worth £1 million.
So there ended up being a lot of different models of the BBC Micro that were produced over the years. Were you there during that entire time, or when did you?
Yes, I was the only board member that was there at the beginning of and the foundation of Acorn Computers, and then when we decided to split it up into ARM E14, which is a company that I then backed as a venture company when I was already a venture capitalist, and we closed down the original Acorn Computers. And I was on the board throughout the entire life of Acorn Computers.
How or when did you know that the BBC Micro was just not going to be able to continue, and that you were going to have to move on to something else?
Well, although we rightly rejected MS-DOS at the time because our own operating system, of course, was so much more advanced than MS-DOS, Microsoft then managed to create a standard with MS-DOS and, of course, developed the MS-DOS into Windows, etc. And we always, in fact, the most amazing aspect of Acorn Computers was that it survived for another 10 years because of the combination of a assembly-written operating system, which gave it its incredible performance, and the ARM, because we created the ARM, and of course the later versions of the BBC Micro were all ARM-powered. So although the PC became a standard, we outperformed the PC for another 10 years in the combination of using a much better processor, the ARM, which had not just a much better performance in terms of the execution of the programs, but because of the barrel shifter in the ARM, mainly, it also had much better graphics performance than the PC. So it was remarkable that in terms just of the raw performance figures, Acorn managed to keep up and actually stay ahead of the IBM PC and MS-DOS, but we could not compete with the standard because all the programs, of course, became programs that only ran on PC-compatible computers. So that was when we realized that we really had to branch out to the ARM processor and concentrate on the ARM processor. And the second processor that people are not. Have you heard of the FirePath processor?
I have not.
So Sophie then did not go to join ARM, although he's one of the inventors of the ARM computer, but joined another company that I founded called E14 to do the FirePath, which was a completely new vector processing chip. And the amazing thing is that Sophie was, of course, responsible together with Stephen for the architecture of the ARM, which a large proportion of the population in the world uses every day, and then went on to do the FirePath, for which the same is true. So you probably don't know that you use the FirePath every day. But if you have an ADSL connection, 80% of all the ADSL connections in the world are terminated in the office by the FirePath processor that we finally sold to Broadcom, and Broadcom has this 80% market share of ADSL termination lines, and that's all FirePath. And she is still churning out new versions of the FirePath every year for Broadcom.
I had no clue about that. That's very interesting. You guys really set the tone there for the future. I'm curious, when you guys were talking with the BBC, and Clive Sinclair was a competitor at the time, and during the entire time of the BBC Micro. Did you have any interaction with or meet Clive?
Yes, well, Clive was of course, he was greater than life. He was probably the most famous inventor. He called himself the inventor, and he had he was a very colorful, or he is a very colorful character. He became famous for the Sinclair Executive, which was the first inexpensive calculator that people could buy. And actually, Chris was the one who sold the first prototype together for Sinclair, Chris Curry, my partner. And so he became famous for the Black Watch. It was the first digital watch in Britain, and audio components. And then, of course, the ZX80, which was at that time, and the Sinclair Spectrum, which was the main competitor to the BBC Micro. It was cheaper, but didn't have as many facilities, and most importantly, didn't have a proper keyboard. It had a dead flash keyboard, as we call it. So there was tremendous competition between Sinclair and Acorn at the time. It was a wonderful period because those two companies, because we were both in Cambridge, and of course Chris and Clive were quite close, and there was even a bust up once because when Chris put an ad in the big papers saying that we were a much more reliable computer than the Sinclair, there was a little fist fight in the Baron of Beef, which is between Clive and Chris. But I've known Clive for many years, and he's a very pleasant and a very intelligent and very charming person, but he does have a temper.
How much do you think the involvement with the BBC contributed to the success of the BBC Micro?
Oh, it was invaluable, both because of the name and then the promotion in the BBC literacy program. But of course, we paid a 10% license fee for that. So we were also responsible of reducing the TV license fee in the UK. So in the UK, there are no ads on the BBC, so you get all the programs for the license fee that you pay. So everybody in the UK pays a license fee to receive BBC programs, and because we paid a license for the BBC name on our computer, that reduced the license fee for the nation at the time.
So tell us about the reunion of the principals that were involved with the BBC Micro that happened in 2012. You were a part of that, right?
Yes, well, it was wonderful to have everybody back together. One of the things that I'm very proud of is that the spirit of this dedication to excellence and innovation in Acorn that we managed to create during the time of the BBC Micro remained in the Cambridge environment long after Acorn had disappeared, and our business school created a sort of a spider diagram where they showed that there are really three main sources of what's called the Cambridge phenomenon, which is 2,000 of our high-tech companies surrounding Cambridge University. That's Cambridge University itself, Cambridge Consultants, which is our probably number one consultancy company, and Acorn Computers. So, we've spun out, or hundreds of companies were created by Acorn alumni.
So do you stay close to the people that you worked with at Acorn?
I do, yes, and we've funded a number of companies by Cambridge alumni, most notably, of course, E14, which was done with Stan Boland, who was my last managing director at Acorn Computers, then became managing director of E14. Then we backed iSierra with him, which became a chip company that was sold to NVIDIA. And now we're backing him in a new venture called 5AI, which is an autonomous car company.
So the movie Microman came out about this whole story, and I think it's a great movie. I like that movie. What was your involvement in the movie?
Well, people come to journalists come to see Chris and me every now and then to write about this story because it's it's a very exciting story. And they said they wanted to make a film, and there are a number of people who wanted to make films, and so I didn't really. And they asked me to be an extra in it, and I said, nah, it's probably not going to be all that interesting. And I regret that I said no, because I think it's a very good movie, and it's not perfectly accurate, but it's accurate enough, and they get the gist of the story, and I think they did it extremely well. So we just told them the story, and the sort of unlikely parts of the story, like the one where I suggest to cut the umbilical cord to make the system work, are actually true. So
yeah.
And I'm sure Stephen probably validated that.
So I think a couple people actually were extras. Wasn't Sophie? I think Sophie was in the movie, right? Just very briefly.
Yeah, Sophie was the only one that was. Yes, she was the barmaid in the last scene. Yes.
Yeah. What did you think of the actor who played you in that movie?
Well, Matt Lynch said, Herman, you can retire. This guy is more you than you yourself. I thought he was fine. The only line that I objected to was a line where I say that Austrian wines are terrible, which it's just wrong. Austrian wines are absolutely wonderful. So but that's the only thing that I think that got wrong in the movie.
So to kind of wrap it up with the BBC Micro, what did you like best about the hardware?
Well, it was that we made an expensive decision giving the BBC Micro a proper keyboard. In order to keep the price down, most other companies had some sort of lousy keyboard, but we went for, we really spent a lot of money on a high quality keyboard so that people could actually use that keyboard and type. In fact, there were lots of books written by Cambridge academics on BBC Micros. So surprisingly, the keyboard was actually a key quality feature. Then it was the fact that it had a proper operating system that could deal with, that was accessible through BBC Basic. So the environment, when you switched, the other wonderful thing, of course, was that the whole operating system and BBC Basic were in ROM. So when you switched on a BBC Micro, it went bing, and there it was. Within seconds, you could use the computer. So none of this booting up and waiting for the computer to be ready. And the thing that you saw is the greater sign, which was the prompt for the BBC for BBC Basic, and you could start writing, hello, print hello world, and it would print hello. So you were right in the basic environment. But then you could use star FX commands. So when you used the star followed by lots of runs, you had direct access to all the operating system facilities. So you could change the color of the screen, you could change the resolution, you could do the networking that I said by, we made a very simple logon command which says, I am Johnny, and you were logged on to the network. So it was actually way ahead of all the computer kits that at that time really were the competition. So we had a proper operating system, and then we had the networking as well, which was with a file server written in 6502 assembler as well. So there was a proper file server with, where you could catalog. You had a cat command for, a list of all the files that you had on the file server. You could save and load commands from the file server. So it was actually quite a sophisticated computing environment.
Do you have any of the old hardware, any of the old machines sitting around your house?
Yeah, I have them all at home, yes.
Oh, do you?
Yes,
Okay.
and there's a Cambridge Computer Museum that has all the versions of the original Atom, the Acorn System 1, as we called it, System 1, System 2, System 3. System 3 was a Eurocard rack system before the Atom, which was the forerunner of the BBC Micro, and then the Archimedes series of computers, which were all ARM-based, but still were BBC Micro compatible. So all the software would run in emulation mode, but the ARM was so powerful that it ran the 6502 emulation faster than the original 6502.
Right. So you've been very generous with your time to do interviews. Do you enjoy talking about this topic?
Well, it brings back very happy memories. It was one of the most wonderful periods in my life, and I've been very lucky because, I'm a deep technology guy, and there are more and more of these really exciting deep technology breakthroughs happening now. So I'm having a ball now as I did then, but it probably was because I was a lot younger then. It was probably the most exciting time in my life.
I think I've pretty much come to the end of my questions here. Is there anything else I should have asked or that you'd like to say?
No, I think you've covered it pretty well, and I hope it was useful and gave you the information that you wanted.
It was a lot of fun. I really, really enjoyed hearing about those times and what you guys accomplished some really, really neat stuff, really cool stuff. And I'm sure you're very proud of everything that you've been involved in over the years. So want to express our appreciation in everything you've done. And there are a lot of people who are really interested in those old machines. And I've got a BBC Micro sitting next to me here that I'm trying to learn about. I'm
Well, in that case, you know many of the features that I've been talking about.
Yeah, but I'm based in the U.S. and we just didn't see the BBC Micro over here much, so I had to get mine from somebody in the U.K.
No. Okay.
If you know of anyone else who was involved that might be willing to talk with me, please let me know, and I would appreciate any help there. But between you and Steve, I feel like I've gotten a pretty good handle on the story here.
I think you probably do. Yes. I mean, there's Sophie, of course, that you could talk to, or Chris Curry, but I think you get the real, in-depth technical advice from Steve, and a bit of the history of the company from me.
Okay. Well, thank you very much, sir. I appreciate it.
Okay.
Enjoy the rest of your day. All right.
Bye-bye.
Bye. Okay, that does it for this episode of Floppy Days. I want to give out special thanks to Hermann Hauser for donating his time to talk with me for this podcast. I also want to thank Steve Furber for helping me get in contact with Hermann. I've provided links in the show notes for all the great websites we discussed during this podcast. Just go to floppydays.com for the full list. Also, I very much encourage you to provide feedback for the show at iTunes or on the website, via email at floppydays@gmail.com, via Twitter at floppydays, or on Facebook at facebook.com/groups/floppydays. Floppy Days is available for streaming at Stitcher.com, and for Android users can be downloaded from Google Play. Finally, you can ask Alexa to stream Floppy Days from the TuneIn service. Just say, Alexa, play the podcast Floppy Days and listen to the latest episode. Until the next show, pull out a vintage computer and compute as if it were yesterday. Bye.